Hello there. My name is Jacob Kaplan, and this is my video 5 for ME210 Dynamics, which covers rigid body motion. So, for this video, I'm pushing a chair at the top of the headrest with a force of 7 pounds, which converted is roughly 31 newtons. And so, the chair weighs 12 kilograms. The coefficient of friction between the chair and the floor is 0.3. And so then, what if we want to find the normal reactions of two legs A and B? So, let's start with our givens and assumptions. So the mass of the chair is 12 kilograms. The force that I'm pushing the chair at the top of the headrest is 31 newtons. And the coefficient of kinetic friction, as the chair is moving, it is not static, is 0.3. And then the lengths of each individual member will be provided in the free body diagram on the next slide. And then, of course, you can't forget that gravity is 9.81 meters per second squared. So, how do we find the reactions at legs A and B? So here we have our free body diagram, which has all of the forces and what distances they are located at in relation to the center of gravity G. And we also have the inertia diagram, showing that the chair is only moving in the x direction. And so, how do we find the reactions at legs A and B? So, we have three unknowns here: the normal reaction at A, the normal reaction at B, and the acceleration at x. So first, we have to find our two equations of motion for the x and y from our free body diagram and inertia diagram. And then after that, we can get our third equation, which will be the sum of the moments that each force acts upon around the center. And then, since we now have three equations with three unknowns, we can solve each equation each at a time to isolate each individual variable and then plug them back into each other to find what the normal reactions of A and B are. So it's a little more involved work, as there are three equations and three unknowns, but you can easily solve them by using substitution.